Okay, this is section 5.3, Algebra 2, page 329, inverse functions and relations. Okay, you'll remember that a function, for every member of the domain, there is exactly one member of the range. So we're going to talk about relations too, not just functions. Okay, but it's important to understand inverses. On page 329 it says, recall that a relation is a set of ordered pairs. The inverse relation is a set of ordered pairs obtained by exchanging the coordinates of each ordered pair. So inverses, we exchange the coordinates forgot another one, I think. The coordinates of each ordered pair. Okay, so I'll give you an example. Let's say that f of x is a function and it's defined by these set of ordered pairs. So a negative 2, 4, 0, 10, 2.5, 12, and 5, 20. Okay, so f of x is these set of ordered pairs, a negative 2, 4, 0, 10, 2.5, 12, and 5, 20. If that is the case, the inverse, and this is how we label the inverse, it is f, it looks like f to the minus 1 power of x. This is the inverse. What happens then is we just switch the x and the y. So the domain of the first one becomes the range of the second one, and the range of the first one becomes the domain of the second one. So it'd be 4, a negative 2.
You don't switch the signs?
Nope, just switch a and b, or x and y, excuse me, not a and b, but just switch. Now, what's really strange is I give these on tests and things, and a student will be exchanging them, and then for some reason they'll write the exact same point that's above. So it's really easy to do, and I've seen a lot of kids miss this on the quiz or test by doing that. Okay. Now you see that this is if it's a set of ordered pairs. However, we don't always get f of x as a sort of ordered pairs. Sometimes we get it as this, as an equation. Okay. So I'm going to teach you then how to do the inverse, and we're going to graph it too to show you what happens. To get the inverse, we want to not work with f of x. So the first thing we want to do is we want to replace f of x with y. Oops. Now, that just allows us to work with it easier, okay? It's not anything, any great thing. It just allows us to work it. So y equals 2x minus 5. Does everybody see that? Once we have y, and if they give you y, that's awesome. You don't have to do this step. Okay? Exchange x and y. By the way, does anybody remember doing this in Algebra 1?
No.
Okay. So exchange x and y. So in other words, x comes over here and 2y minus 5. Okay? The next step is we solve for y. Okay, so I'm going to add 5 to both sides. So I have x plus 5 equals 2y. And I'm close. I just have to divide by 2. And when I divide by 2, I divide everything by 2, and I rewrite it in slope-intercept form. I rewrite it in slope-intercept form. So I write it as 1/2 x plus 5 halves. Does everybody see that? And then, one last step, we replace y with f negative 1x inverse. So we go f negative 1, and I'm going to switch it. I'm going to put it over here. Does everybody see that? Okay, so I want to graph that now. I want to graph the original and that one. So, and you can do this on your graph paper, or you can, I'm going to rewrite them up here so you know what they are. The first one, the original, f of x was equal to 2x minus 5. You remember that? And then we did the inverse of x as 1/2 x plus 5 x. Okay. All right, so I'm going to graph the first one. I go down 5, 1, 2, 3, 4, 5, and my slope is 2, up 2 over 1, up 2 over 1. Is that correct? And we do a straight edge. And graph it. Okay? The other one is up 2.5. So up 2.5 right here. And then my slope is 1/2. So I go down 1 and to the right. Nope. I go up 1 and to the right 2. Correct? Up 1 to the right 2. Up 1 to the right 2.
Where'd you go? 2.5?
Because 5 halves is 2.5. Uton.
Oh.
So that's a y intercept, right? Okay. You good?
Up 1 over 2.
Yes.
Okay.
Okay. Up 1 over 2. And then I'm going to put this line. Okay? And if I extend this one, they intercept. Do you see that? And they intercept right here. Now what I want to show you is that every graph and its inverse is a reflection over this line. This blue line. And that blue line is y equals x. Okay? Listen to this, every graph and its inverse is a reflection over this. So when I was doing these ordered pairs up here, you remember that? If I graphed them, they would still be reflected over that line. Do you understand that? Every graph and it's reflected over that. Okay? Now these two happen to be both functions, but sometimes you reflect something and it's not a function because it fails the horizontal line test, not the vertical line test. But I'm going to give you an example, okay? So I'm going to take this away. Has everybody got that? Okay? I'm going to take this away. And I'm going to do this one. Y equals x squared plus 1. Is this a line?
Yes.
No,
It's a parabola. Okay, so you remember our steps? I don't have them up there. What was our first step?
Replace f of x with
Do I have to do that step?
no.
No.
Exchange x with y.
I exchange x with y, so I go x equals y squared plus 1, correct?
Yes.
All right, now I subtract 1 from, we solve for y. Subtract, so I subtract 1, so I get x minus 1 equals y squared, correct? Now I'm going to take the square root of both sides. And here's the part that students struggle with because they forget to do this. They forget that when you take the square root of both sides, that you have to do plus or minus this side. So you get both. Okay? Now, we're going to graph this. Okay? But I'm going to show you an easier way to graph this. You can plug in points if you want. Okay? But I'm going to show you an easier way. So I'm going to erase my graph here. Remember the lines? Oh, I should have left the blue line. I'll put it back. Okay, so I'm going to graph these two graphs. Let me put them on here. The first one was y equals x squared plus 1. Is that correct?
Yes.
The second one is y equals plus or minus the square root of x minus one, okay? Let's take a look here. I don't know if you remember how to graph a parabola, but I'm gonna take this first one. And if you remember right, that this is the parent graph is x squared. We start at the origin, we go 1 over 1 up. But since we plus 1, we move it up 1. Do you remember that? You move it up 1, right? So this is the vertex, Jaws, right? From the vertex, we go over 1 up 1, over 1 up 1. If this number was a 2, we go up 2, right? And then we go over 2, and how much do we go up? 4. 1, 2, 3, 4, and 4. So this is the original graph. Okay? This is a function because it passes the vertical line test, correct? All right. Now, we're going to reflect it. Remember that blue line I drew? You can kind of still see it there. The line's still there. See? It's this line right here. We're going to reflect it over this line. Now, do you want to do that? Probably not, because it's really hard. So what I do is, I'm going to show you how to do this quickly. See this point right here? What's the coordinates of it? 0, 1. So flip those around. 1, 0. So it's going to be there. Okay. No, 1, 0. This is, oh, I'm sorry. Okay, so then let's do this point. What's this point? Be 1, 2. So we're going to flip it around and go 2, 1. Right? What's this point? Negative 1, 2. So we're going to go 2, negative 1. This point is going to 2, what? 6? No, 5, right? 2, 5. So we're going to go 5, 2. 1, 2, 3, 4, 5. 1, 2.
Once you have that set, like once you have the first one set, you know which direction it's going, can't you just?
Yep, you can. Oh, you can just use symmetry, right? And so it looks like this.
Well, I'm just saying, like, once you get the first one and you know that's the vertex, you can just go over 1 up 1, over 2 up 4.
Yes, you can, going sideways. Did you hear Bo? He's right. Once you get that vertex set, you can just go over 1 and up to the right. You're going to the right, right? Look how this is reflected across that line. This is a function. This is not a function. Why? Because it fails the vertical line test, right? You can tell horizontally, the book says if you draw a horizontal line here, you can tell that its inverse is not going to be a function. But that's how that looks. All right? Now remember, if I put a number in front here, you know, if I put 3x squared, you go over 1 and then you triple whatever this is. So it was 1, it goes up 3. This one goes up 4, you go up 12. You triple it. If I put a number right here, do you remember that? Okay, all right. All right. Questions so far? Anything? Okay. Now, what happens if I give you an inverse function, or I give you two functions and I say, are they inverses of each other? Okay, so let's say that I have f of x equals 3x plus 9. And g of x equals 1/3 x minus 3. And I want to know, are these inverses of each other? Well, you could go ahead and just find the inverse of this and see if you get this. But I'm going to teach you the composition of them. What do I have to do is I have to check fog, since we did that yesterday. And if that equals x and goth of x equals x, if both of those are true, they're inverses of each other. If either one of them are false, they're not. So if I do fog and I get negative x, I can quit and say they are not inverses of each other. Do you understand what I'm saying? Let me show you. Okay? Let's take the first one. Okay? This one and this one. I'm going to take fog. So f of g of x. So I'm going to put x in the g function, which is this, and then I'm going to place it right there. So I have 3 times, this is what you did today, for today. I have 3 times this plus 9. Does everybody see that? I took all of this, put it in for that x. I took all of this, put it in for that x. Now I simplify. So I bring this through, and I get 3 times a third is 1. Did you know that? So 1x minus 3, minus 9, excuse me, I forgot to bring that through, plus 9. What's a negative 9 plus 9?
0, 1.
So I get x, don't I? So I'm good. I got x. Now I do Goff, which is g of f of x. And this time I put x in for f, right? So I have 3x plus 9, and I'm going to put it right there. So I have 1/3 times 3x plus 9 minus 3. I put it all right there. When I distribute through, okay, 1/3 times 3x is x. 1/3 of 9 is 3. So I get x plus 3 minus 3. I get x. Therefore, this is a big fat yes. Those are inverses of each other. Okay? Now I'm going to show you ones that are not. Okay? Let's say that f of x equals 4x squared. And g of x equals 2 square root x. Okay, if I find fog, f of g of x, I put the x in the g, and so I put 4 times 2 square root x quantity squared. So I take all of this and put it in for that x. When I square this, I get 4 times 2 squared is 4x, right? 2 times 2 is 4, and the square root of x times square root of x is x. That is 16x. Did I get x? No. I can stop right there, because it both have to be x. Harper, you get that?
Yeah.
Okay. So don't continue on if the first one doesn't equal x. All right? Okay. Any questions about that? All right, let's go to your assignment then. Page 333. Okay, we are going to end up doing numbers 11 through 26, comma, 30 through 35. I'll have one of you write that up there, I guess. Jaws, go ahead. Okay, and I'm going to do, I'm going to look at I'm going to look at 26. On 11 through 14, we just switched the order of pairs around, correct? On 11 through 14, we just switched the order of pairs around. On 15 through 23, maybe we should look at 23. Okay. Number 23 looks like this. F of x equals x plus 1 quantity squared plus 3, correct? What is that? Parabola. It says find the inverse of each function and then graph the function in its inverse, okay? I'm going to do this one. We're going to put y in here, aren't we? Okay? And I want to show you this. This is x plus 1, right? And then what do we do?
Switch y and x.
Switch it x and y, right? Correct? Okay, people, I want to show you something. Do not foil this. It will make it very difficult. We're going to subtract 3 from both sides. Okay? And then we're going to take the square root of both sides. Now, when you take the square root, what do? You get a plus or minus. X minus 3, y plus 1. Now what? Nope, you gotta move the 1 over. So it's -1 equals y, and then you replace it, don't forget this one, we replace it with this, y, and I turn it around, so I do plus or minus the square root of x minus 3. When I say I turn it around, I put the inverse on the left side and all the rest of it on the right. Okay, now that's really hard to graph, isn't it? Well, let's graph this one. Let's go up here and graph this one right here. Because it says graph it's the original and then the inverse, okay? So where do I move this parabola? Not right, it's backwards in the parentheses. So this goes left 1. What about this? Up 3. Very good. This one is the correct sign. The one inside the parentheses is the opposite. So when I do that, okay, I'm going to go left 1, watch this people, you with me? Left 1, up 3. Does this parabola go up or down? It goes up because the number right there is 1, correct? And it's a normal one. It's not 2 or anything, so it goes up 1, over 1, up 1, over 1, up 1, over 2, up 4, right? So it looks like this. Now, it's my opinion that do not use a t-table on its inverse. Just take each point and flip them. Actually, Bo would say, this is -1, 3, right? So we want to go 3 and -1, right? And then Bo would say, which way is it going, right or left? Parabolas that go up go right. Their inverses go right. Parabolas that go down, their inverses go left. So Bo would say go down 1, up 1, right? Like this. And then go over, down 2, and 4. Did I get that right? I'm looking at it sideways. Okay, so it looks like this. Do we understand that? Doesn't look right. Over 1, up 1. 1, 2, 1, 2, 3, 4. Oh, I missed it by 1, guys. Sorry. Sorry about that. There we go. Okay. You see how I did that? Dalton? Any
This is the second time you got my name wrong.
And I didn't get it at the same time. I messed it up twice. Different people.
Yeah.
Alright, sorry about that.
You have to label that or anything?
Nope. Nope.
That's the whole answer.
That's the whole, well, the first answer was this, sir. And then the second answer is this. I'm just gonna call you sir and ma'am because I can't figure out names right now. Okay. Alright, sorry Dawson. Alright, this is due Monday. Nope, Tuesday. And you have a quiz Tuesday, right? Alright.